should have everything written in your plan book from yesterday, but in case you don't, today is 124 to 129. Again, all these homeworks are up in my Google Drive folder, so if you are struggling, excuse me, please ask your parent to go check the Phoenix update and get that link, or they can text or email me, and I will send them the link if they want it. I'm sorry, I won't get it straight to you. If your parent makes that choice, that is up to them. But right now, it is just for adults to be able to help you out. So right now, with what we've talked about with probabilities, we've all been talking about one event. Sorry, and if you're heading your notes, you want to head it with compound probability. And you can abbreviate probability, but please write out the whole word for compound. So you could abbreviate probability with prob. 127, and today is, of course, the 11th. So compound events mean multiple things happening, right? What are the chances that you'll go get ice cream and go get pizza? Well, pizza probably first, but what are the chances that you'll buy, like, you'll go to the store and you'll find a new pair of pants and a shirt that goes with it? What are the chances that, like, we'll eat outside today and we'll get rained on? Like, multiple things happening, right? Chances we eat outside today are pretty high. Chances we get rained on, I highly doubt it, because this week actually looks great. So when we start talking about multiple events together, things get a little interesting. And sometimes we talk about and situations, and sometimes we talk about or situations. So the first thing we're going to talk about here deals with some chores. So here's some questions to keep in your mind as we go. How's this probability related to the probability of a single event? Either what event or what other event are we interested in? So like, what are we actually looking at? What's the favorable outcomes? And does our answer make sense? Like, of course, probability has to be between 0 and 1, remember? So if we get an answer over 1, we know we've done something wrong. So Thomas helps around the house. Hopefully you all do chores, otherwise you're not pulling your weight at home. And they have a chore wheel to determine what he does. So here's Thomas's chore wheel. Rake leaves, do laundry, clean bathroom, vacuum, clean bedroom. Real quick, draw a sketch of that on your paper. Just like make a circle as best you can, and then divide it out. And you don't have to put like clean, but put like, you know, bathroom or BR, and like vac for vacuum. You just put bed for bedroom. So we have only 2 of these wedges given to us. We have a 4th and a 3rd. I need you guys at your teams to figure out how can we determine the missing pieces of these probabilities. So if we look here, 1 should be real easy. What wedge up here should be real easy to figure out? Why clean bathroom? It's the same as vacuum, so this is also going to be a 1/4 chance, or a quarter of the spinner. So how much of the spinner is left on the left-hand side? Adrian? Half. So all 3 of these together are a half. We know clean bedroom and these wedges are the same sizes. Take, I don't know, like a minute and a half, a couple minutes. Try to figure out how big are these little wedges for rake leaves and do laundry. With your team. We're assuming it's like fall or something like that. We're assuming rakes are part of that. So maybe in the winter that switches to like shovel driveway, or in the spring it's like water the plants or something like that. Clean bedroom's a 3rd. You cannot see that very well up here. Clean bedroom is a 3rd. You could work with the entire thing and subtract away from it, or you could just work with the half and subtract away from it. If we start with the half, because I don't have a lot of group conversations happening yet, Brody, if we start with the half, what do we want to take away from it? To figure out, we'll just put both of these sections together right now. So what do we want to take away from the half to get blue left over? We don't actually care about the right side right now. We already know everything on the right side. We only care about the left side. Yeah, we're going to look at half the blue area, but first we got to figure out what the blue area is. Kevin, what do we take away? What do we?
Oh, 4/12 we take away.
You're already, so you already went to common denominator. I love it. But first, let's look at it just how it is. To figure out how much is in the blue region, I need to take away the green region. Right? So my 1/2, I got to subtract 1/3. Now to do this, what do we need before I can subtract fractions? Common denominator. Thank you, Layla.
Everyone's going to say it together.
Gosh, guys, you're not doing the group participation with Layla. So, now hold on. So Kevin said 12, right? Could be the common denominator. I agree. But there's a smaller one. 6, right? How do I turn this into, so please write this on your paper, 1/2 minus 1/3, because we're going to figure out the blue region. That will equal whatever my blue region is. And we've decided we're going to be working in sixths. How do I convert 1/2 into sixths? Anybody?
3.
Nobody said it right.
Multiply it by 3.
Nope.
3/12.
3/3. Be careful. We got to talk about it as happening on bottom and top. We're not multiplying by 3. We're multiplying by 3/3. Over here, we multiply by what over what?
2/2.
2/2.
1 or 1.
And we get 3/6 minus 2/6, right? 1/6. Okay, so probability of rate leaves is 1/6? No. That 1/6 is this entire section.
So you just split it in half.
So what's, now hold on. Think about this for a second. How much is half of a 6? Now I forget if it was in this class yesterday or not. Who knows what of really means? What, Ava, was it you that told me yesterday?
It's multiplication.
Of means to multiply. So if we think about half of a 6th, anyone have a prediction? 12th, right? Because we multiply straight across the top, multiply straight across the bottom. So each of these regions is 1/12. 1/12 here, 1/12 there. Questions? Now we can check this. If I make a third into 12ths, I'd multiply by 4/4. Right, so if this is 4/12ths, how many 12ths do I have in total over here? 6/12ths, right, Ethan? So is that a half? 6/12ths is a half, right? So if I check this, 4/12ths, 1/12, and 1/12, that's a half. Now, we don't always want them to just do one chore, though. So we figured out the probability of doing laundry, right, is 1/12. So if you want to mark on your paper that that was 119A, you can go ahead and do that. But Thomas hates to clean the bathroom, right? I actually kind of like it because then you have a nice clean bathroom. But Thomas hates to clean the bathroom. So when he spins the spinner, what's the probability that he will not point to clean the bathroom? So now we want to investigate, and please write this appropriately. So we now want to look at P of not bathroom. We can abbreviate that, not bathroom. Work with your team, take like a minute or so, figure out what's the probability of not cleaning the bathroom. Probably don't even need a minute. I'll give you a hint. Does it need to be a denominator of false? You doing all right? Guys, everybody's paper should have P parentheses not bath on it. Right? We should write out what we're solving for. Oh, you're on that page. I can't keep up with how you take notes, dude. So, if I want to not do the bathroom, what do I want to get rid of from this spinner or not to land on, Jalen?
Delete it.
Okay, but in math, how can I do that? Subtract what? No. Subtract the 4. Sorry, I'm going to use cards here in a second. I know I'm just kind of taking random answers from people. We want to get rid of the bathroom from the probability. So we subtract 1/4. Now, I have the 1 there because the entire spinner is 1, right? Because the probability of landing on the spinner, well, of course that's 100%. I'm going to land on the spinner. So what's 1 minus 1/4? 3/4. So our probability of not cleaning the bathroom is 3/4. Which actually, that means there's a 75% chance he's not cleaning the bathroom. If no one cleans the bathroom, that could go for a while. End up looking like the frat house did. Questions on this? The fraternity house, which is where like a bunch of guys live together in college. So there's groups in college you can join called fraternities or sororities, and because they're like really old, they're gender based because you can't like have mixed genders living together in college. Well, you can, but like a lot of colleges wouldn't allow that. So they would have houses that are the fraternity house for like guys or the sorority house for girls, and you have to join the club to like live there. But then sometimes they have a reputation for like a bunch of boys live together and it gets gross. So that was a joke.
My dad lived in one of those houses.
Yeah. Depends on where you go. I had a great experience in my Greek organization. All right, now hold on. I'm gonna leave my spinner up here to help you guys out. Hey, up on the TV. Thomas now hopes for either, right? He's like, I don't want to clean the bathroom. I'm fine with cleaning my bedroom because then I'll be able to find my math book. Or I'm fine with raking leaves. So I'm okay to go outside. So what is the probability that he will either clean his bedroom or rake the leaves? So do we think, I'll call on you, but I want you guys to talk on your own first. Do we think that his probability will get smaller when he opens up the option to 2 different things, or that it will get bigger, and how can we figure that out? So first thing you might want to think about, what is the probability of just cleaning bedroom? What is the probability of just raking leaves? And then what happens when we put them together? When we say either. Take a minute or 2 to talk about this with your group. I'll walk around and take questions if you got them. I'll leave my spinner there, but we're talking about either bedroom or leaves. So I'll go ahead and help you guys out with some color up here. Either one, bedroom or leaves. Nice, they're right beside each other. What is the probability he'll land on either?
Okay, so since they have a common denominator, and one person what we just had.
Yes. Is that how to write it? Because I was about to show that. So can I come back to you real quick? Hey guys, when we go to write this, we need to write our probability statement. So again, P parenthesis. But what would go inside of here? Well, no, that's what P parenthesis means. Joey, what would go inside my parentheses? Yeah, P parentheses. So we could say no, not bathroom. Bedroom, right? Bedroom. Bed or rake. It's a shorter word. Sorry.
Wait, what's
bed or rake. Sorry, this should really be capitalized.
Bed or bake?
That's an R. I mean, if you want to bake some cookies for me, I'll take them.
Oh, I'll bake
wait,
myself.
wait, my mom would make cookies and bake.
There are like 24 people in this class.
No.
Okay. Guys, I'm baking cookies for all of you.
Alright, sorry, you had a question.
Yeah, okay, I have a question.
Yeah.
So, since both denominators and then both
Sounds good to me. You want to do it up here or just talking through it? Sure.
Yeah,
show what work you like write on your paper. So I'm gonna say what Ava just said as she writes. So Ava just said, now how she's writing the work is mildly confusing, but I'll explain it in just a second. Ava said, since they already have, Casey, join us, because I doubt you're talking about the math. Thank you for being honest, I appreciate it. So, what Ava said was, since they already have a common denominator, and I want to put them together, right, look at both regions together, she said, can I just add them? Like, we're already ready to add, we've got the common denominators. So she sets up, now, here's my opposition of how she wrote it. In my brain, I would need to write 4/12 first, because that was clean bedroom. Plus 1/12, so she just switched the order of addition, which is fine. You can do that, it's totally good. And we get 5/12. So this probability of either, please make sure you have on your paper, comes out to be 5/12 when we add the regions together. So when I put on ORs, do we have this written down? When I put on ORs, my probability gets easier, right? What if I say, what's the probability of cleaning bedroom or raking leaves or doing laundry? Well, now I add in another region and my probability gets better again. Then if I say or everything not bathroom, it gets better again. Every time you add an or, you get a higher probability.
I don't know if this is true or not, but like in my brain, it kind of makes sense. Isn't it every time that you say or, you're just adding?
It depends on the situation we're talking about, but with probability, yes. If we're talking about one spinner, one game, something like that. So imagine playing a game where you're rolling a die, and you have to get a 6 to win. Versus if you're playing a game with a die, and you can get a 5 or a 6 to win. Which game would you rather play? Yeah, the second one, right? Because it's easier. It's got an or, more options to win. So with the chores, I don't know if we'd call that winning, but if he gets what he wants, I guess, it's not in the bathroom.
You get to win money.
Sure, if you get an allowance. Took me a long time to get an allowance.
I don't do chores, but I don't get allowance.
Oh. All right. I honestly don't know how to pronounce her name. Can anyone help me pronounce her name? Now I don't know that that's right, but all right. Miss N. Hey, hold up. We can't be so unstructured if it doesn't work well. Miss N lets her students borrow pens and pencils on days when they have a quiz. Nah, you guys got to bring your own. She had a paper bag containing hundreds of wooden pencils, mechanical pencils, and blue pens. You know, blue's the best. Stuart! Hey, you don't all have to share about the fact that you own a pencil. It's okay. Stuart forgot his pencil, and it's quiz day. So Miss N tells him that 1 out of every 3 students who reach into the bag pulls out a wooden pencil. 2 out of every 5 students pull out a mechanical pencil, and the rest are going to end up with a blue pen. So we need to be able to compare these probabilities to say which one is most likely. So let's write down what we know, and then we'll start to manipulate things. What do we know? What's one thing we've been told? I lost my pen. What's one thing we've been told? Casey? Yes. Either Mr. Smith can write you a note, or you can just tell them I just sent you. What's one thing we know? One thing they tell us, Riley?
That Stuart forgot his pencil and that some kids got wooden pencils and some of them.
What do you mean some? Give me math. What's the statement say? Stuart forgot his pencil on his quiz day. Miss N tells him that. Second paragraph.
Okay.
1 out of...
One out of every 3 students gets a wooden pencil.
So we know wood pencil is 1 out of 3. Hey guys, we're not in choir. I don't know why I have to remind us of that. And it's not really funny, actually. Like the fact that 7th graders can't figure out not to sing in class. My wife used to teach elementary phys ed. She quit because she couldn't take it anymore, and education's kind of broken in a different way. So like, I'm lucky I get to teach math, but specials is really tough. she was good with elementary kids. I'm not. So if you're going to walk in, you're going to have elementary behaviors, just walk right back out. Right? You can go watch my video lesson if you can't handle being in class. I'm not joking when I say I expect 7th grade appropriate classroom behavior in here. Write down what else you know. It's given in the sentence. We should have a book in our group. She tells us one other thing. What's probability mechanical? 2 out of 5. Be careful, it's not 1/2. So we need to figure out the probability of a blue pen. And I'm just going to put pen because it's not like there's other pens in there. She just has boxes of blue pens she'll add in there. Work with your group. Those are the only 3 things in the bag. So how do we figure out the remaining probability that is there? Doesn't matter how many there are, we're just trying to figure out probability.
Oh, okay.
Yeah, we should.
What do we need before being able to really compare fractions? Common denominator. Common denominator. It depends on how you look at the problem. What are we going to use as a common denominator here? Anyone? 15.
And the numerator is...
Just solve it on your paper. Don't look up here unless you need help. Don't look up here unless you need help. You and your team got this.
Oh my goodness.
Now, Layla asked, is this an addition or subtraction problem? And I really should have, Jalen asked, and I really should have just said yes. I love or questions where you can answer yes. Because first, I'm gonna add these, right? Because we already have 5/15 of the probability taken up. We already have 6/15 of the probability taken up, which means together, how much has been taken up? 11/15. Which means that remaining for the blue pens is everything 1 take away that fraction.
This makes no sense.
What do you mean?
It makes all the sense in the world.
What do you mean?
Like, I don't understand why you're getting 11/15. Like, I understand that we're subtracting.
Alright.
Did you multiply there?
Yes, common denominator. Times 3 top bottom times 5 top bottom. Is that what didn't make sense?
No, I got
Okay, so with me. I got a bag, but we can see through the bag. First thing she tells us is wooden pencils. The probability of getting a wooden pencil is 1/3, or when we manipulate that 5/15. Okay? Mechanical pencil is 2/5 or 6/15. And that with pens, okay, the blue pens, is everything in the bag, right? Everything in the bag is 100%. It's all of it. So it's 1, right? 100% is 1. So when I start to look at what is only the blue pen, I take away wooden pencils. I get rid of them, right? So I take away 5/15. Right? So I'm going to take that away. But also, at the same time, I'm going to take away mechanical pencils. Because I don't want the... So together... I like being dramatic. Welcome to my classroom. Together... Those are 11/15 that I just took away. And I'm going to take it away from 1 because that's the entire bag. So what I have left with the blue pens is going to be whatever's left over after I take all of that away, which is all of the pencils put together. So I added the pencil probabilities. We got 11/15, and that's really just probability of getting a pencil. Either type of pencil. When I take that away, I'm left with 4/15, which is the probability I'll get a blue pen. Does that make sense? If not, I'll explain it another way.
Yes, sir.
Okay, if we imagine this bag,
understand why we're subtracting. Like, that's what I don't understand.
So I love that you still don't understand it because you're pushing me to be a better teacher. Okay, for real. We could also look at this situation. No, you don't have to if you don't want to. As here's the bag, right? It's a two-dimensional bag, but just imagine we're looking down in the bag. Everything's nicely sorted. So when I look down in the bag, a third of it is wood pencils. Right? 2/5, which is kind of a pain to draw. 2/5 is slightly under a half. So if I draw, oh sorry, that is also 1/3 I should label. This is mechanical. It's 2/5, which really, if we start comparing things, is 6/15. This is 5/15. Okay, now forget the hundreds of pencils. Right? Ignore what Miss Ann said. Her bag only has 15 things in it. Of those 15 things, 6 of them are mechanical pencils. 5 of them are wooden pencils. And if we have 15 total, how many pens must we have? 4. Out of the total 15, and that's probability. Does that make sense? Okay. Wonderful. Thank you. We have like 4 minutes left. Thank you. I liked it when I threw things also. So, hold up. We got one more problem to rock. Problem 122, we're going to drag it down. One more problem to rock. So, Felicia, bye Felicia, is trying to add these parts, right? This is kind of what we just did. But Felicia's looking at 1/3 and 2/5. Notice that these rectangles are both the same size, right? So each of these, if completely shaded, would be a 1, right? So this is 1/3 shaded out of a total 1. This is 2/5 shaded out of a total 1 because if I shade the whole thing 3/3 or 5/5, like that's going to make a whole 1. So Felicia thinks that the sum of this is going to be go straight across the top, go straight across the bottom, and she's wrong. Because, for that to make sense, Felicia has the same size rectangle. Now, don't do this because this is wrong. Felicia has the same size rectangle, and she thinks in the end, sorry, I realized it was getting hot in here. In the end, she only has 3 of these regions. Like, no. What do we need to do if I'm doing this with the rectangles? So don't give me the other mathy words. What do I need to do here to be able to work with this problem? Somebody knew that I'm going to cards. Right? So what do I need to physically do here? Like if you were going to instruct me what to do. Do you know? Yeah? Okay, go ahead. But then I realized Ethan's hand was up and I haven't talked to him at all. So go ahead if you want. Very fun.
So you could split that thingy.
This one? These are wrong, so let's erase that. So this is 5 pieces, this is 3 pieces. How could I cut them?
You would split the one to 3 pieces, you would do it, you would split it with 4 lines.
Yeah, to make it 5 different regions, right?
Yeah.
So total, I have 15 now. How many out of 15? 5.
Yeah.
Here, what would I do?
You would
Split it 3 ways, right? So 2 lines. Now that didn't quite look right. And I have 6 out of 15. What should she actually get in the end, Ethan? 11 out of 15.
That's what the answer was last time.
Wasn't the answer 4?
Yeah. Oh, yeah, but
Right, but it was part of the other problem. So, here's really what that's meant to wrap up. Common denominators are meant to make pieces the same size. That's it. That's why we do common denominators. Make sense? Thank you very much. Ava, especially thank you for pushing me to continue explaining. Oh, are you sure you texted the right number? Did you text the day or the night number?
I texted you right now. I texted you the
Right now? You texted me right now?
Why'd you say right now?
Yeah. 50289. Yes.
I told you I found my math homework.
Let me check my phone. I don't think I did.